Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's show is the moon. And here to talk with us all about it is our guest, Robert Reeves. Robert, welcome to the program.
It's wonderful to be here. I always enjoy talking about the moon.
Well, great. Well, we've got the next 22 to 23 minutes to talk all about it. But before we get into that, why don't you tell our viewers a little bit about yourself and what you do?
Well, I'm retired now, technically. I'm almost 80 years old, which means I am just the right age to have been old enough to understand what the space program was when it just got started back in the 1950s. So when we first started going to the moon, it got my attention. And I've been an astronomer ever since then. I've um, had my Celestron 8 telescope for 50 years now. The same telescope I bought, got it just in time for the total lunar eclipse of May of 1975. And
75.
I still have that telescope. Of course, it's grown. I now have a telescope for every day of the week, but the moon has remained an interest, and I've written a number of books about it, including my last one that was put out just last summer, a photographic atlas of the moon, published by Firefly Books up in Canada. It's available at all bookstores and Amazon, of course. And over the years, I've become fairly well known regarding the moon and astronomy, and I'm very proud to have been the first Westerner to address the Chinese Academy of Sciences in Beijing about the moon. So a lot of good rewards have come my way just because I love to play with the moon.
Absolutely. That's quite an honor and a distinction to be able to speak to a national body like that on your topic.
It was fun.
Now, getting into the moon itself, something I get asked when I'm at a public observing event, people ask, can we see the American flags on the moon?
Well, actually, um, with the 4th of July coming up, I've been asked that question a lot too. And actually, there are two answers for it. The first one, unfortunately, we can't see the flags directly from the Earth. No telescope is powerful enough to resolve the largest flag on the moon is the Apollo 17 flag. It was 6 feet wide. It is too small. And to show you the limitations of observing features on the moon, I once spoke with Yuri Beletsky with the European Southern Observatory. He had access to an 8-meter adaptive optics telescope, which produces the sharpest views of anything from the Earth. His goal was to try to see the 150-foot long shadow of one of the Apollo lunar landers at sunrise. And even with the most powerful telescope available, he could not. So the flags, they're 10 times smaller. So we're not going to see them from Earth. But they are visible to satellites in orbit around the moon. The Lunar Reconnaissance Orbiter has photographed all of the Apollo landing sites, and the Apollo 12, 16, and 17 flags are still standing. We can see their shadows being cast on the ground. Now, we know the Apollo 11 flag is not standing. Buzz Aldrin and Neil Armstrong put it less than 40 feet from the center line of the Apollo 11 lander. They never ventured far on that very first expedition, and Buzz Aldrin saw the flag blow over when they lifted off. The rocket exhaust blew it over.
Oh my.
So my hope is that it also blew a lot of dust onto the flag so that it's been protected from solar radiation over all these years. And that in the future, 50, 100 years from now, an archaeological expedition to the original Apollo landing site might recover that flag if it's been covered in dust and protected. Now, why am I worried about it being protected? Well, the Apollo 14 and 15 flags, we don't see their shadows. We think what has happened to them is the intense ultraviolet radiation from the sun has made the nylon on the flag brittle, and they've simply disintegrated, fallen apart. Of course, the other flags are probably in similar shape, but at least they're still standing. Now, there's nothing special about the flags. Each flag put on the moon by the Apollo astronauts was just a standard government issue nylon flag. They cost $5.50 back in the 1960s, ordered out of a government supply catalog. So the only modification they did with them was to put a stitched hem at the top of the flag so they could insert the aluminum rod to support the flag so that it would look like it was flying, even though there's no air or wind on the moon. So uh, the answer is no, we can't see them from Earth, but we know they're there because we have satellites in orbit around the moon that can see them.
Interesting, interesting. I'll have to relay that information to folks at the next observing site that I attend and let them know just what the situation is.
Yeah, well,
Now,
if you point out the Apollo 17 landing site, you might mention that that flag is larger than the other standard flags that flew on the earlier missions. It's 6 feet wide. That flag actually flew to the moon on Apollo 11 and came back to Earth. And then it was hung in mission control for Apollos 12 through 16. And then Gene Cernan and Harrison Schmitt took it back to the moon and planted it at the Taurus Litra Valley. So the Apollo 17 flag that we see is still standing has been to the moon twice.
very, very interesting, very interesting. Now, what if Earth never had a moon? What would have happened?
If Earth never had a moon, we probably wouldn't be here chatting about the moon. Now, without a moon, the Earth's geology, its biology, its climate, and if humans had actually evolved, our philosophy would be different in many significant ways. Now, of course, if Earth had no moon, the very creation of the moon would have never happened. Right now, the leading theory about lunar creation is a small Mars-sized planet that we hypothetically call Theia was in close orbit near the Earth after the solar system formed, and eventually the Earth and Theia collided. Now, the iron and heavy elements from Theia were gravitationally attracted to the debris of the larger proto-Earth, so that enhanced our metallic core that gave us a stronger magnetic field, protecting the surface of the Earth from solar radiation. Now, not like infrared or ultraviolet radiation, but the energetic particles from the sun. The actual radiation particles that won't just give you sunburn, but well, it'll kill you. So without the added mass of Theia's core, our magnetic field would be less, and our protection from space radiation would be less. Now, another thing is, after its creation, the moon was about 10 times closer to the Earth than it is now. Its gravity was, or no, the tidal pull of the moon was fierce compared to what it is now. And once the Earth's oceans formed about 3.8 million 3.8 billion years ago, the moon's gravity created enormous tides, hundreds of feet high, that washed way inland. And this constant churning of the ocean is what we think mixed up some of the early chemistry that allowed life in the oceans to form. And of course, the moon also, gravity also helps ocean currents. So without the moon, the Earth's oceans would become stagnant, and it would be difficult for anything more than just pond scum to form, and uh, intelligent beings uh, uh, like we see on our planet now would probably have never evolved. Now, in addition, our climate would be enormously different. The moon's gravity, the moon's circling the Earth, helps stabilize our the tilt of the Earth's axis. It keeps the Earth spinning um, in a regular rotation instead of slowly tumbling where it would alter the seasons. Imagine the North Pole facing toward the sun continuously, the whole northern hemisphere, a continuous daytime, the southern hemisphere, constant nighttime. It would be, and additionally, without the moon, the Earth would rotate much faster. Our present 24-hour day is a direct result of ocean tides interacting with the moon. The early Earth, spun perhaps every 4 hours. So that would create a wildly different environment on the Earth, and likely intelligent life would not have formed or evolved. So we've got to look up at the moon and thank it for our very existence. It's not just a beautiful thing rising above the horizon, the romantic full moon that inspired lots of poetry and prose. We owe our very existence to it being there. And of course, if humans had evolved on a moonless world, our literature, poetry, and prose would be vastly different. Uh, uh, Ancient civilizations either worshiped the moon as a god or they feared it. They superstitiously feared it. So ancient civilizations, the moon held a great sway over them. And of course, as we evolved as a society, the moon worked its way into literature and poetry, and eventually we get to the point where we have the technology to travel into space. Without the moon, we probably wouldn't be the spacefaring nation that we are now because there would have been no magnet to pull us into space, no reason to go into space. We owe a lot to the moon.
I
Humanity owes its existence to it, and a good deal of our culture is because of the moon.
indeed, indeed, it's more than the moon in June,
No,
so to
not at
speak.
all.
That's
It
for
is
sure.
very much wrapped around the very psyche of the human beings. There's evidence that, archaeological evidence that as much as over 20,000 years ago, early man was paying attention to the moon. There's carvings on bone that coincide with the cycles of a monthly cycle of the moon. Now, of course, this probably wasn't a scientific interest in it. It was probably more a timekeeping function or some sort of religious function. But man has had his eye on the moon for quite some time.
Yes, he has. Now, since NASA has already explored the moon, why should we bother to observe it?
Well, the moon is the only other world that human beings have explored. And it as much as the moon propelled the technology of the 1960s and 1970s and gave us the standard of living that we have today. So much of the technology we have, our very ability to talk back and forth right now about this topic over this internet connection, that evolved directly from all of the technology developed during the early space program. So uh, the moon played such a central part in our daily lives, whether we realize it or not. And of course, being the only world that human beings have set foot on, well, it naturally has our attention. And we can look up and know there are American flags on the moon. There are American footprints on the moon. And they've been joined by robotic emissaries from India, from Japan, from Russia, a number of other countries. And uh, the international China, of course, has a very successful lunar program. So it's going to be more and more part of our daily life. More nations than just the United States are going to the moon, and science and our standard of living is going to benefit greatly from that. But on a more personal level, um, let's face it, the moon is about the only object that you can reliably see from inside of a big city. I live in the middle of San Antonio, Texas, city of 2 million. If I go out and strain on a moonless night, I can just barely see the Big Dipper. Not too many stars in the sky, but you're going to have no problem finding the moon if it's in the sky, if it's in the evening sky, or finding it in the morning if it's not cloudy. So the moon laughs at light pollution. It is a natural target for our telescope. Now, so many astronomers think, oh, the moon gets in the way of my deep sky observing. I can't see the nebula and the star clusters. No, well, that may be true, but uh, the moon is an alternate target as well. It should not be ignored. It has so much geology, so much features on it. It's not just a round ball covered with bumps and holes. Each one of those features has a story to tell. If you understand the geology of the moon, how the moon formed, how the face of the moon was created by only two different forces, either impacts or volcanism. And you can trace how those interacted with each other. You look at the moon through a telescope, and you can see a crater on top of crater. You can see craters on lava fields. You can determine the ages of these things. Um, the one on top is obviously the youngest, and the one on the bottom is obviously the oldest. If it formed on a Mare surface, that volcanism has a date too. So it's not that difficult to understand the interaction of features on the moon just in a modest telescope. So
Well,
it's
and that's very true. Yeah, as we were just saying. We're going to have to take a quick break. Uh, if you have a question, please send us an email. The address is down there at the bottom of your screen. And coming up next is Term of the Month with Stephen.
Thanks, Don. The term of the month is TNO, which stands for Trans-Neptunian Object. It's any minor planet that orbits the Sun at an average distance greater than Neptune's. There are a bunch of names for subsets of the TNOs, including classical Kuiper belt objects, resonant TNOs, which resonate with Neptune, scattered disk objects, and detached objects, which include the sednoids. As of February 2025, nearly 5,900 objects with an average orbital distance larger than Neptune's orbit are in the Minor Planet Center catalog. You may have heard this term as part of the announcement in May of 2025 of the object 2017 OF201. Cheng, Li, and Yang discovered it in archived telescope images in the Dark Energy Legacy Survey from 2021 to 2018, and archived Canada-France-Hawaii telescope images from 2011 and 2012. The orbit is from 45 AU to 1630 AU and lasts a whopping 24,000 years. It was last at perihelion in 1930. It's estimated to be at least 550 kilometers, that's 340 miles, in diameter, but could easily be 700 kilometers, which would qualify it as a dwarf planet. And that is the term of the month, TNO, Trans-Neptunian Object. Back to you, Don.
Thanks, Stephen. We're back with our guest, Robert Reeves, discussing the moon. Now, Robert, what can the full moon show us that astronomers didn't understand until the space age?
well, actually, astronomers have been trying to understand the moon for since the telescope was first applied to astronomy by Galileo over 400 years ago. But astronomers aren't geologists. They did not really understand what they're looking at. And it took a geologist to finally decipher what the moon has been showing us, staring us in our face all along. We can look up at the full moon with our naked eye and see the story of how the moon was created. Each of the dark spots that make the eyes and the nose and the crooked mouth of the man in the moon were created by massive asteroid impacts. And particularly the man in the moon's left eye, Mare Imbrium, one of the largest circular dark spots on the moon. It's lying in a gigantic basin, and a basin is nothing more than a huge crater. Now, that was not recognized until the very late 1800s. Astronomers never made the connection on that. The head of the U.S. Geological Survey back in the late 1800s, a fellow named Carl Grove Gilbert is the one who made the connection. He spent 3 weeks looking at the moon through the Naval Observatory telescope in Washington, D.C., same telescope that was used to discover the moons of Mars. And his conclusion was that Imbrium was created by a massive impact. He saw features radiating away from the Imbrium basin that told him that material ejecta scattered radial away from the Imbrium basin, and it was a massive impact that created that. But his writing about it was tucked away in the archives of the U.S. Geological Survey and not recognized until the beginning of the space age. In fact, it was Gene Shoemaker who unearthed it and promoted the asteroid impact theory of crater formation and basin formation to the point where people accepted it, and more and more people began to understand this. But the evidence of that, looking us straight in the face, our entire human existence, but we didn't understand what made those dark spots. They are giant craters on the moon created by an asteroid impact that later filled in with lava and made them dark. So the key to understanding the face of the evolution of the face of the moon was staring us in the face all along, not recognized until geologists got their finger in the pie at the beginning of the space program.
Well, that's interesting that we were able to finally figure that part out. Now, what is the best area on the moon to observe with a small telescope?
Follow the shadow. It doesn't matter what phase of the moon it is. Look at the area where it's sunrise or sunset. The division between the sunlight side of the moon and the dark shadow side of the moon.
The
And there
Terminator.
you'll see, that's a technical term for it. Yes, the Terminator has nothing to do with Arnold Schwarzenegger. It's the division between light and dark on the moon. But that's where you will see the most detail because there's shadows that provide contrast and let you see details. Now you think, well, why not look at the moon during the full moon? Then you can see the entire globe of the moon. Well, there's no shadows during the full moon because it's very flatly illuminated, and a majority of the features on the moon will disappear. Of course, that's the best time to observe the Maria, the dark regions of the moon, see the whole face of the man on the moon, but details on the moon, craters and mountains, they will seemingly vanish because there's no contrasty shadows. So follow the shadow, no matter what phase it is, from the crescent moon that I call the Cheshire Cat moon, because you look up and it's just this thin smile, like the cat in Alice in Wonderland who disappeared until only his smile remained, up through the quarter moon, which is well placed in the evening. For observing the moon split in half, just a half phase. Look along the Terminator for some very fascinating geology. And of course, towards the full moon, the bigger the moon gets, keep following that shadow. Because over on the more brightly lit side of the moon, you will notice the detail is that you saw last week. You can't pick it up anymore because there's no shadows. But keep following that shadow. And then finally we have full moon, and then the moon phases shrink again. And again, you follow the shadow as it makes the moon disappear instead of appear, like it does in the waxing phases. So there is always a good part of the moon to look at. It's the division between the sunlit and shadow side.
Yeah, I've found in my own observing that it's, again, with a full moon, you don't get any contrast. The light is coming straight towards the surface of the moon and then coming back straight towards you. Plus, even with a neutral density filter, it's still quite bright.
Now, one feature that you can see better at full moon are crater rays. The fresh craters that are less than 1 billion years old have this bright splash of material, like Tycho crater and Copernicus crater. Those crater rays, the material on them reflect best back toward the light source, the sun. And at full moon, the Earth is between the sun and the moon, so crater rays are brightest at full moon.
Well, in about the minute that we have left, Robert, is there anything you'd like to tell our visitors who might be interested in looking at the moon?
Well, it's a object that you can see from your own backyard. The moon laughs at light pollution. So with any optical aid, a pair of binoculars, a small telescope, even a big astronomical telescope, if you're lucky enough to own one, look at the moon as often as you can. See how the phases grow, how the shadows change, how the features pop into view. The moon is not static. It changes every night. The shadows are different. The appearance of it changes even hour by hour. You can watch sunrise creep into a crater and watch the crater come to life. All of these features have a personality once you observe them often enough and become friends with the moon.
Well, Robert, I want to thank you very much for taking time out of your schedule to talk to us about the many special things about the moon. To our viewers, please visit our website. The address, as always, is down at the bottom of your screen. And coming up next with What's Up in the Night Sky is Stephen.
Thanks, Don. What's up in the night sky for July 2025? The solstice was late last month. Days are getting shorter in the north, in the south longer. Seems odd now that summer and winter are just getting going. First quarter moon is on July 2nd. Full moon is on the 10th. The third quarter is on the 17th, and the new moon is on the 24th. Here we see Mercury and Mars on the 1st of July at sunset. Mercury is in Cancer and sets an hour and a half after sunset to, at the end of the month, 45 minutes before sunrise. And that's because inferior conjunction is on July 31st. Mercury is best at the beginning of the month because of the inferior conjunction. Mars goes from Leo to Virgo and sets from 3 hours to 2 hours after sunset. And so it is also best at the beginning of the month. Then we have Venus, Uranus, Neptune, and Saturn shown here on July 4th, yippee for the United States, shown at sunrise, a couple of hours before sunrise. Venus goes from Taurus to Gemini over the month and rises 2.5 hours before sunrise all month long. Uranus is in Taurus and rises from 2.5 hours before sunrise to 5 hours before sunrise, and so is a little better at the end of the month because it's farther from the sun. Neptune is in Pisces and rises from 4 hours after sunset to 3 hours after sunset, and so is best at the beginning of the month. Saturn is in Pisces and rises from 4 hours after sunset to 3 hours after sunset and is also best at the beginning of the month. Then we have Mars and Jupiter shown on the 31st of July at a couple of hours after sunset. Jupiter is in Gemini and rises 15 minutes before sunrise to 2 hours before sunrise, and so is better at the end of the month. Note that Jupiter is near Aldebaran, which is not the same as Alderaan, which was a planet that was destroyed by the Empire. Then we have Pluto on the 24th, right around midnight. Now Pluto is in Capricornus, as it has been for a long time. Meridian transit, that's where the planet is highest in the sky, is near midnight. Opposition is on the 25th of July. And that is what's up in the night sky for July 2025. Remember, we don't charge money for this show, but we may tax your brain